Welcome to the video. In this video I'm going to show you how to make racing bar graph out of any data set in Windows using Python. So first of all, I want to tell you that to do this you want to install certain libraries or modules, you can say. So those are matplotlib, pandas and numpy. So if you want to install these packages in Windows using pip install commands, it will take a lot of time and it is not necessary to do that. So there's a tool for that. You can just install that and start writing code. So that tool is called as Anaconda. So this is the Anaconda download page. The link is there in the description. So if you go there, you can see here it is telling that you can quickly download 7500 plus Python or R data science packages. So you can just ignore about R language. It's a pretty different language than Python. Right now we are using Python only. So you can see here in the right side they have mentioned that some of the packages are pandas, numpy, matplotlib. All these packages we're gonna need in the process of coding the racing bar graph. So moving on, just click on download and you will get we'll go to the download section. Here you can see that it needs either Python 3.7 or Python 2.7 version. So you have to go to Python's download page. This link is also there in the description. You can just go here if you don't have Python already and install Python 3.7.7, not 3.8, because you can see here it is telling it is built, or you can use this Anaconda packages only in 3.7 version or 2.17 version. So I recommend you to download 3.7 version. You can click on Windows executable installer file and you can just install Python in your Windows. Then just go here and click on either of these two links according to your system capacity. After you download, I have already downloaded it. So after you download and open the exe file, you will get this setup. Click next, agree, just me, not for all users. Here you can see that I have already installed Anaconda. So I'll just to show you, I'll select different folder. So I have created a demo folder just to show you how to install this Anaconda, because there are some steps you need to follow. So it has to be Anaconda 3, not Anaconda underscore demo when you install it. Then click next. It will gonna show the warning that your folder name consists of one space. So you can just ignore this. Click on OK. Here you need to select the second checkbox. Click OK, and don't select the first part. Click on install. So once the install is completed for Anaconda, you can see some of the tools in your computer. Let me search for Anaconda, and you can see here there are a few things here. The main thing is Anaconda Navigator. Let me tell you few things about this. I'm gonna open this now. So once the Anaconda Navigator is open, you can see this on the home page. Here you can see applications on base, that is the root environment. You can see there are no other environments right now. So if I click on environments, you can see there is only one environment, that is base. Let me tell you what is these environments. Suppose you want to use a separate environment and install certain packages only on that, and you can use that environment in your coding part. You can do that, but here in the by default Anaconda Navigator shows you the base environment, which is by default it will install, and these are the packages which are already on that environment. You can see there are a lot of packages. So if you think these packages are redundant and if you don't need these, you can just create one more environment. You can click create here and install whatever packages you need, to your coding, and then activate that environment and start your coding. But right now the base root is a default and I'm gonna use it as of now. So if I go to home, you can see there are a lot of applications in this environment. These things have come by default, and VS Code, that is Visual Studio Code, which I'll be using for my coding, is already installed in my computer. But if it is not installed, you can see here there is an install button like this. You will have here also, so you can just install VS Code or use any of your code editor. But I recommend using VS Code because it is little simple and easy to use. So it's already there here and it's showing in this environment. What you have to make sure is not to open VS Code from any of other places, like in your computer you go to the exe file and open VS Code. If you open like that, the Anaconda packages might not be connected by default. You have to do some settings. So I recommend open the Anaconda navigator, come here and click launch. If I click launch here, the Anaconda libraries will be by default connected to the VS Code, and you will not get no module found errors while importing packages from Anaconda. So right now it's opening VS Code in my computer. If you don't have VS Code, you can just install from this Anaconda navigator or from the direct link from the VS Code download page. That link is also in the description. So once the VS Code is open, I have created an example file here in VS Code, um, a Python file, and you can see here in the left bottom there is a line saying it is using Python 3.7 and the base environment has been activated for Conda. So this tells, I'll click on that. You can see here there are different versions of Python in my computer as of now. So one is Python 3.8, one more is 3.7, and one more is Python 3.7 connected with Conda. The environment is base as of now. So this is what you need to have before starting coding. Let me show you opening a terminal here. This is what I said. You will not use Anaconda command prompt for the coding. You will use the terminal of your code editor. So you can see here when I open the terminal, a command ran, Conda activate base. This command will only run automatically if you have opened VS Code from Anaconda navigator. That's what I have done now. So whenever you open terminal, this command is gonna run. That means it's activating the base environment. You can also activate other environments if you want to code on that, as I told, and you have to install packages on that separately. As of now, I'll be using only base. Now I can just import any of the packages in the base environment of Anaconda and start coding. So let's start building racing bar graph. Before going to the actual coding of racing bar graph, I want to show you the basic use of all these modules, starting with NumPy. So let me show you opening Python interpreter. You can just type IPython and it will open the interpreter. Here I need to import NumPy as np. I'm importing it. I'll be defining two arrays in NumPy. So it is pretty similar to the list in Python, but it's not actually list. I'm defining b as one more array. Also, to show the use of these NumPy arrays over Python's list, I'm going to define a list here with same values and the one as 3, 4, 5, 6. So if I do A1 into B1, that is multiplication of two lists, it's going to give error. But if I do A into B, which is two arrays of numpy type, so I'm gonna get an array which is element wise multiplication, like from A and B. So you can see here 3 and 1 and 4 and 2 is the element wise product. So the basic use of NumPy module is to do calculations related to mathematics. When you are dealing with statistics, you have to do that. You will deal with matrix and then matrix multiplication, element wise multiplication, which is not easy in Python's list. So this is the use of NumPy. Now I'm going to show the use of pandas and matplotlib. Pandas are used to retrieve data sets. So I'm going to show you how to retrieve data from a CSV file now. So I am initiating a variable A and I'm using read CSV function of pandas library, read CSV. Then I have a CSV file in the desktop folder already, and it is named as book1.csv. Always remember to change these slashes, otherwise it will give error. So there are other options after this parameter here, but we will talk about it when we are coding for racing bar graph. If I click enter and see what is there in A, I can see the data has been retrieved from CSV file, and a.info will give me all the info about this data frame. So data in pandas, after you retrieve data, it is stored in a data frame type. So here you can see there are 4 columns, 1 2 3 4, and each column has 5 non-null values. So this is the use of pandas. I can also convert these data frames into the NumPy array type, and then I can do any kind of mathematical operations on these. So this is the basic use of pandas. Let me clear the screen, and now I'm going to show you the use of matplotlib. I am going to define two arrays here. One is 1 2 3 4, and one more is 10 20 30 and 40. So now I'll be using matplotlib's horizontal bar plot, which is the one we'll be using in racing bar graph. So x and y axis has to be given here, and when I give empty.show, this window will pop up and show the horizontal bar graph. So these are the basic uses of all these libraries. So let's get into the actual coding of racing bar graph. This is the first part of racing bar graph code. So I have already imported pandas for reading data and matplotlib to plot the graph. So in the next line I have defined a value df, and I have used a link here instead of a CSV file, but I have used the same function read CSV, and I have used one more parameter here, use calls, and I have written name, group, year and value. So let me show you what is there in this link. I've already opened it in the browser. Here you can see these are the first line are the column headers, and the first line consists of column headers. So here you can see the column headers are name, group, year, value and other subgroup, city and everything. So this is basically comma separated values but displayed in HTML page. So in my code I have selected only these name, group, year and value. That is for the first row. If I say it is Agra, India 1575 and 200 only. So for your convenience I have opened Python shell also here. So if I copy this code to the Python shell and click enter, and then if I show you the df data, so it will look like this. So it has around 6 to 5 to rows, and I have only selected 4 columns out of these. So the df contains these data as of now. So in the next line I have defined a variable named as colors. So this is to differentiate groups, which we can see here in the second column. There are a lot of groups, India and other things like Europe, Asia, Latin America and all. I want to color code these values, so I am making a dictionary with India as key and its color as the value. So for your convenience, I'll copy this code also to the interpreter. So let me paste it here. So after pasting it, if I want to see what is there in colors, you can see it's a clear dictionary with India as key and the color code as value. So I'm creating as of now for further use later. So in the next line I'm creating a variable named group underscore lk. So this is also a dictionary which will have name as the key and the group as the value. This is to apply color later for the different groups of countries. So if I copy this code also to the interpreter, and if I show that, you can see here these are the city names and the values are the group names. So I have done it using name and group columns. So in the next line I have defined two variables, you can see, with comma, and I'm using subplots function of matplotlib, and I'm setting the figure size as 15,8. Subplots will create sub graphs, and here figure size, that means fixed size keyword, help me to give width and height to the figure, and this function will return two values, two variables you can think. One is the actual figure, the subplot, and one more is ax, axis. So ax variable here, that means axis, will be used to apply all the extra values to the plots, which I'll be explaining in a while now. In the next line I am defining a method here in Python named as racing underscore bar chart, and it takes a parameter, that is a number, which is the year which we want to show the bar chart. Next I am going to define one more variable, it is called as dff, and you can see here what I'm doing is I am taking the year column from df value. We have the df, yeah, this is our df value. I am taking year column, which will have all the years and equivalent to the year which is coming in into this function. So suppose if we pass 2000 or 1575 here, you can see if I pass that, only those data will be filtered, and I'm sorting it with value. So the value will be the other column, and I'm sorting that in ascending order and taking out only 10 data from below the tail. Let me put this in the interpreter. So if I put this, okay, I'm getting error because here is not there. Let me take 2000, and if I show you what is there in this variable, you can understand I am taking only 10 values here, that is from tail. I'm taking 10 values and it is sorted in ascending order, starting from the lowest value to the highest value. You can see it's all from the year 2000. There may be more columns for the year 2000, but this racing bar graph which I am going to build is only for top 10 most populous cities for every year from 1500 to 2019. So I am taking the last 10 data starting from below, that is the greatest value. I'll move up for 10 values and then stop. So only these 10 values I'm taking out. I'm going to build a graph which shows only top 10 cities for a year. So that is what is happening in this line. And the second line, I am using ax variable, which I said, which we will be using throughout to apply all other values to the figure which we got in the first value. So these two are interconnected, so if you apply anything to the AX variable, it will apply to the figure as well. So that is what we did using plt.subplots. So I am using BARH, that is horizontal bar graph, which I said before, and I am using x-axis as DFF name, that is the name of the city. Here for the year 2000, it is this list of 10 cities you saw just now, and then a y value is the value of these cities, that is this column in the end. So these are the two axes, x and y axes, and the color which I am going to apply will depend on the group which I created before. So what is happening here is, for every value in DFF name, consider Kolkata is the first value. So Kolkata will come here in this variable, and group LK of Kolkata. So group LK has what we have in group LK. I'll show you. Yeah, this is what we have. Group LK, we have all these: Agra, India, Ahmedabad, India. So Kolkata will also correspond to a value India when we put group LK of Kolkata, which is the value in X for the first value in DFF name. Colors of India will correspond to this value which we defined here using which I showed you previously. Here India corresponds to a color code here, and that color code will be applied to the color property for this x and y axis. So as I said, DFF name and DFF value will have 10 values, and the first name and first value will be getting the first color code. So I'll just run this now. We can already see the graph here. So let me show you using plt.show. Plt is our matplotlib module, and show is our method, and I will use racing chart, and I'll pass 2000 as a year. So let me execute this file in the terminal using Python, the file name, and I'm clicking enter. Now this code will be run, and a plot should be shown according to whatever we have defined as of now. This graph is shown as of now. You can see here the first value is Kolkata, and for this a color has been applied, and the value is shown here. It's around 13,000, which you saw. So the value has been shown in the bar graph, and for each color code, Tokyo and Osaka correspond to same group, so it has been given same color. You can change these color codes according to your choice. So in the next few lines, I have defined this code, and I have defined a value here dx, which is the max value of all these 10 values which we got in DFF for this year. That will be around 35,000, which you saw here in the interpreter, which I'll be showing now. So here it is around 34,450, and I am dividing it by 200. I'll tell you why I have used this. Then I am using for loop with I comma a tuple with value and name as a variables, and I am looping through DFF value comma name of all 10 values, and enumerate function will give out index also for every loop. So in the first iteration, I variable will have 0, and the value and name variables here in this tuple will get corresponding values of value and name of the 10 column and rows. So what is happening is, for this name and value, I want to apply all these properties to our AX. AX is the plot variable, axis variable. So we can give properties as I said before. So I'm using text method here, and where I want to put this text method, I will define in these two variables, value minus bx comma I. So I am telling value will be, if I consider Kolkata, it will be around 13,058, minus dx. Dx is the value which I said, which I got from the max value by 200. I am subtracting it from the value, and y value, that means we are placing it somewhere. We have to give the text method x and y coordinate. The x coordinates I am giving as value minus dx, that is little less than the actual value of the bar graph, and the y axis, y value will be 0 for the first iteration, and the text, what has to be shown as a text, it is this variable which I got from this tuple, and this contains, suppose here for the first row it contains Kolkata, and what size I want to have this text for. It is size 14. Weight will be the boldness of that, and where I have to place this, either bottom of the bar graph or right side, left side, all these I can specify for this text value. So I have done this for two more text values, that will be placed in the same x coordinate but little down from this value, this text value, and this will be the group lk name, that means the group's name of this city. Suppose if we take the name will be Kolkata, this will be India here. So the second text value I am placing below the name is the group value, and the size and color and the placement I have defined. And the third value is little above value plus dx, little above the name of the city, and its value is always also its value is also the same as I, that is 0, and it corresponds the value of the bar graph. So the value which I had taken from this iteration, I will place it here. This, you can see this flower brackets and all is just for formatting. With comma it will be shown, and the size and the placement I have defined here. So let me show you all this in action by putting plt.show and running this file using Python command. So this is the graph which you will see after applying all these text values. As I said, for the first iteration I'll be using Kolkata and India. So Kolkata is placed, suppose let me take this value of this bar graph will be until here where this color ends. I will minus the value which I got from dx, which I will tell you here, which I got from dx. I have subtracted it little bit from the value, and that is little left side of this. So here it will be placed, the name will be placed here, and in the same x coordinate I have subtracted y coordinate a little bit and have placed the group name, that is India. And the third text property which I have shown you is for the value, and the value is there in value plus dx position, that is little after the bar graph is done. So value, it will be this line, and value minus dx will be this side, and plus dx will be this side, and I am placing it here. So after you run for loop for all these values, 10 values, you can see corresponding texts out here like this. Moving on, I have written 4 more lines now, which are giving again some properties to the ax variable, that is our plot. So the first property is a text again, and it corresponds to the value here. So you can make out of all these values here what is happening here. And the second text is placed here in this coordinate, and it corresponds to the value, this one, population in brackets into 1000. So this has been placed in the plot, and then I am setting some properties to our x-axis. I am setting this format for the ticker here. It is in the format, this comma will be separated for the x values, and I am also saying set ticks position on the top. So you will see the x-axis values on the top of the plot. So let me show you this by running this Python command. So now you can see there is this year value here appearing, 2000 as the value now, and the x-axis values are displayed on top rather than displayed on the bottom, and it has been separated by a comma here, which we have set before. Now I am adding few more properties. I have added these lines, so I'm adding few color and other properties, label size for the parameters, that is x-axis values, and then I'm setting the y-axis text to null. That means I don't want any axis values written for the y-axis. And then I'm setting some margins, and then grid, I'm setting the x-axis grid as line style. I'll be showing that. And then I am setting this axis below as true. Let me show you this one by running it again. So now you can see here that the y-axis, you had these names of the cities, those have been removed, and there is a line in the x-axis. You can see here the vertical line which I have set, and these lines are displayed behind the bar graph. So all these properties I have set now. Now I have added two more lines, these two lines, which are basically text. So one text is of the value most populous cities in the world from 1500 to 2020. It has to be 2019. And then I have added one more text property with a value by our channel name. I will show you this by running the same command again. So now you can see the graph here. On top we got this line, and here in the bottom we got by developers hub. So the graph is pretty much done. Now we have to remove this box which is shown here outside of this bar graph. So I have done that using this property, and I have set it to false. Now I'll show you the final graph product. So this is our graph which is shown for the year 2000. As I said, the box has been removed. So the last part which is remaining is make this graph an animation and run it from 1500 year to 2019. So let's do that with few lines of code. So for that I have imported animation module from matplotlib, and then I have written these two lines after the method. So there's no need of calling the method. So this method here will call the racing bar chart method with the input value starting from 1500 to 2019. So there is no need to call it explicitly. So after that I am going to use the same animator object and save it in an MP4. So to save this animation as MP4 file, you might need to install a module in your Anaconda. It might not be there. You can do that using Honda install ffmpeg. The module is called as ffmpeg. You can just run this command and get it installed. After that I am just saving that, and I am removing this show here. Run the Python command again and wait for the video to be created. So once the command is run successfully, you can see an MP4 file here in the file explorer, and you can just open that and you can see the animated video of your graph, that is the racing bar graph. So you can see the full video of this racing bar graph in the link given above. So click on that and see the video. Before that, let me tell you, thank you for watching. Leave a like if you really like this video, and subscribe to our channel for more videos like this. Thank you once again.